Students, this PowerPoint, this notes, this is all about ionic bonding. Now, first, let's kind of review. An electron dot diagram is also known as a Lewis dot structure, and this is a model of an atom in which each dot represents a valence electron. So what I would like for you to do before we even get started, I would actually like for you to get out your periodic table because you're going to need it, and I would like for you guys to draw the Lewis dot structure for each of these different atoms. Okay, so as it appears on the periodic table, go ahead and draw these. Pause your video and draw them, please. Okay, so if you notice, remember that the group number tells you how many valence electrons there are in each atom. Sodium has one valence electron because it's in group 1. Carbon is in group 14, which means that it has 4 valence electrons. You can either go clockwise or counterclockwise, but the rule to remember when drawing Lewis dots is that every side gets 1 before any side gets 2. Oxygen is in group 16, so it gets 6. Xenon is a noble gas, so it has 8. So we draw 1, 2, 3, 4, 5, 6, 7, and 8. Magnesium is in group 2, so it has 2 valence electrons. Elements that do not have a complete set of valence electrons tend to react, which means they either need to gain them or losing them. And by reacting, they're going to achieve those configurations or like how the electrons are arranged, similar to those of noble gases. Some elements achieve this configuration through the transfer, which means that they either lose them or they gain them between atoms. Chemical properties such as reactivity, melting points, and boiling points, they all depend on how the electrons are arranged in the atom. And we call this arrangement the electron configuration. When the highest energy level is occupied, then we say that it's stable and it's happy. When that last level is occupied, those atoms, those ions, will not react with anything. Noble gases have 8 valence electrons, so that's why they're inert or unreactive, except for helium, because helium is in the first energy level, and that first energy level can only hold 2 electrons. So it's full when it has 2. That's why helium is on the noble gas side, but only has 2 electrons. An atom that has a net positive or negative charge is called an ion, and there are 2 specific ones. An anion is an atom with a negative charge, and a cation is with a positive charge. The easiest way to remember the difference between the two is that the cation right here has that T. That T looks like a plus sign, so that you know that the cation is positive. Remember that electrons can move to a higher energy level when it absorbs energy. So a lot of times cations form when electrons gain enough energy to escape from the atoms. A particle with a positive charge will attract a particle with a negative charge. So we say that opposites always attract. So the positives and the negatives will match up and they'll bond together. This is a chemical bond. A chemical bond is the force that holds atoms or ions together as a unit. That creates a compound. Ionic bond. An ionic bond is the force that holds cations and anions together. So specifically, an ionic bond is going to be between a metal and a nonmetal, because metals tend to be cations and nonmetals tend to be anions or negatives. So those positives and negatives form. So let's take a look at this. We did sodium. Remember that sodium has 1 valence electron. Chlorine, because it's a halogen, has 7 valence electrons. So sodium, in order to become stable, wants to leave. Chlorine, to become stable, wants that 1 electron. So when sodium loses, it becomes the sodium ion. So it's positive. And when chlorine gains that 1 electron, it becomes the chloride ion. That +1 and that -1 attract each other, and a chemical bond is formed. Here are some other examples. Potassium has 1. Chlorine has 7. Potassium and chlorine bond together because when potassium loses the 1 electron, it becomes positive. Chlorine, when it gains the 1, becomes negative. This positive and negative attract each other and they bond together, creating potassium chloride, or KCl. Let's look at another one with magnesium and oxygen. Whoa, sorry about that. Magnesium has 2 valence electrons. Oxygen has 6 valence electrons. Magnesium, in order to become stable, it wants to lose these electrons. And oxygen, in order to become stable, wants to gain those electrons. When magnesium becomes a cation, it becomes +2. When oxygen becomes an anion, it will become -2. +2 and -2, they attract each other and they bond together to create magnesium oxide. Now here in this picture, this is a figure in your book. Okay? You can kind of follow the maze around. Okay, so if we follow lithium around the maze here, through the pipe system, maybe. So if you follow its pipe all the way around, okay, lithium and iodine want to bond together, because if you notice, lithium is +1 and iodine is -1, so that +1 and -1 cancel out to become lithium iodide. You can do the same thing for bromine, because bromine is -1 and potassium is +1. You can have potassium bromide. Now, if you look over here to barium, barium is +2, so it wants to bond with something that's -2, but we don't have anything that's -2, so this barium would actually result in the dead end over here. Oxygen is -2, magnesium is +2, so those two create an even bond to become magnesium oxide. And when you're writing your chemical compound, you always want to make sure to put the cation first and the anion second. If you have any questions, go back and re-watch this video. Thank you.